So here we go. Part 2, Crewton Ramone's House of Math with the third power algebra. Fooling around with Sydney in her very last lesson. From me, anyway. Well, who knows? It could happen when we have more. And here we just made a simple one where I have an x to the third, a negative x squared with a positive x squared, and a negative x. Is what that drawing is supposed to represent. And so my factors are x plus 1 and x squared minus x. And the whole thing is just an x to the third minus an x. I'm just getting warmed up, figuring out what goes on, how it works when we cover stuff up. And then we've got a complicated one over here, where we first started off with the two factors. Right? We just counted the sides. Right? And the sides were x squared minus 2x minus 3. There it is. There's my x to the third, right? But the one factor, this long factor right here, point to the one side. That'd be you, point to the one side. Over here. Yeah. Is x squared, right? Well, we cut some off, and this is the important part, this is the fun part. We cut off 2x, right? And 3 units. And since we count the big ones first, it's still x squared minus 2x minus 3, right? Even though the minus 3 actually comes first. We always count the big ones first. Okay? Because people will, well, how come it's not x squared minus 3 minus 2x? Well, because that's not how we count. We don't count, right? We count in descending order. Okay. And if you look, you can see under here hiding, there's some x, right? There's 2x there and 2x there. Oops, I just made a mess. Okay. And then here's a couple of negative x squareds. So again, all we're really doing is counting. And what we have in this picture right here is we have that. We have, there it is in physical reality, and here it is on the paper. And we looked at it like this. So, right? So it's oriented this way, even though we're sitting on the side over here. And now, I said, well, we took a look at it and we counted, and we could see that this side very clearly was x minus 2. Anywhere along there, it's x minus 2. It's x minus 2. So one factor is x minus 2, and the other factor is x squared minus 2x minus 3. And when we multiply those factors together, we get x to the third minus 4x squared plus an x plus a 6. Alright, now, being fun, say, well, okay, why don't we turn into a division problem? Now, she doesn't like division. Make your division problem face.
I didn't say that.
make your division problem face. She's not doing it, but anyway. Whenever we bust out division, she doesn't make a happy face. Let's put it that way. Okay, but all we're doing is counting. I told her, look, the division is actually easier than the stuff we were just doing, because I give you the whole rectangle. Right? I give you x squared minus the 4x plus the x plus the 6, and I tell you what one side is, which is x minus 2. Your job is tell me the other side, right?
Factor it.
So she was saying, well, could I factor it? And I'm like, yeah, of course you could factor it if you knew how. But you could also just do division, which is what they teach you in textbooks. And see, here's 18. And if I know one side is 6, the other side's got to be 3, right? And you could factor 18 with one side being 6, right? So if you know the factors of 18 are 6 and 3, then if you know I've already given you 6, then all you got to do is put 3. And sure, that's the same thing here. If I know the whole thing is x squared minus 4x plus x plus 6, man, it takes forever to even just say them. And I know that one side's x minus 2, then the other side has to be, you're right, x squared minus 2x minus 3. But most kids can't see that. Most kids don't know how to draw the picture. Most kids have never ever seen anything that looks anywhere remotely like this. They've never had third power algebra with blocks before, or manipulatives, right? In fact, I've seen textbooks that say you can't do it. I mean, like, you know, you have to have a, like I said, a big 3D animation thing in a computer. No, we're just going to say super simple with arithmetic. So let's do it. What are we going to do? What do we have to do? Well, we do it just like we do regular division, where I take this and find out how many of them are contained in here. Okay? Now let's fool around with this, and I can't hold the camera and do all the explaining and stuff like that at the same time, so we'll come back in a minute. Okay. So there we have it written out. I have, how many times is x minus 2 contained in x to the third minus 4x squared? We don't have the squared sign there. Put the little 2 on the x. Here. That's you. need a 2 there.
Just a normal 2? Like
X squared. Ugh, what are you doing? Here, I'm talking about.
You want me to put it up there? Like,
Yeah, it needs to be, we gotta know what kind it is. It's not just 4x, it's 4x squared, right? And she draws a microscopic 2. Alright, there you go. Okay,
My
so
bad.
x to the third minus 4x squared plus an x plus 6. Here is the drawing of it. Oh, excuse me, here is the actual behind, the actual blocks, the actual physical model that we made. Right? And what we said is, there's all the pieces. Yeah, there's you. Go ahead. You can put it so you can see what's going on. We know this side is x minus 2, and we know that this side is, now we got to count it. So, we're going to count it. So, what's the first thing I go across when I go across here? If I had my little min, I should have a little man here to tell me. What do I see? I see an x squared. Right? Here, I'll even let you... We did it once already down here, where we played with this, right? Now we're doing it a second time to make sure she gets it and she has to do it. So, what do we go across first? Here. Okay, good. So, what's that?
X squared.
Yeah, so we're going to put the x squared?
On the bottom.
Yeah, put it up there.
Alright. That's on the bottom.
Well, first over here. Put it there.
Here.
Yes.
X squared.
Okay. Now we put it there because that's where the x squared's going. I see guys do this on YouTube. I see guys do this all over the place where they put the x squared over here. That's not where the x squareds go. The x squareds go over here.
Why?
Because that's where the x squareds go. It's like you asking if I put 100, right? And I do it by 10, do I put the 1 there?
No.
Right? It's the same thing. I put the 1 there. Right? Okay, same thing.
Should I erase that?
We just happen to be in base x. Yes, we should erase it. Get rid of you. But that's the y behind it. Sure, use your paper. Go ahead. Okay, so now we got to be able to see what we did. And what we did is we went across x to the third and 2x squared. So you have to write that down.
Third.
Right here, underneath. Look, 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 look. Just like that. Just like you're doing division, which you love so well.
Third.
Right?
It's so confusing.
Okay.
It's weird.
But it's less confusing now that you can see it, right?
Yeah.
Okay. So put a line underneath that. Dude, we're just doing division. There's no... Yeah, okay, fine. Now, when I multiply this times that... Okay, this is true, but let's leave that here for the moment. Because we have exactly the opposite of what you did. Because we have a positive x to the third, when I multiply that times that, and even there it's a positive x to the third. And then we get a negative 2x. There's my negative on top, 2x squared. 2x squared. So that sign symbol right there should be a negative. Okay, so what are we doing? We're keeping track with the symbols of what we just did. Because we could just put up there x squared minus 2x minus 3, but I guarantee you any teacher that sees you do that is going to tell you you cheated. Because there's no way you could just do that and draw a picture in your head and blah, blah, blah. When you try to explain it to her, they're like, no way. Right? So you have to be able to keep track and show, okay, what we did there is the x squared. See it? Alright, now multiply. Oh, well, actually, we already did the multiplication. Now subtract is what I meant to say. Okay, so when I subtract, that means I counted that, right? So I subtract this whole quantity, right? So when I subtract this whole quantity, that means that's negative, and that will become positive, right? Because a negative, negative, I minus a minus. Okay, so when I do that, then I wind up with none here, and I don't need to write a 0, but I have none there, right? And I wind up with negative 2x squared right there. Okay, so now the x.
Plus x.
Plus x, right? Plus x.
Oh, I can't write like that.
Well, you don't need to write the plus 6 yet.
X.
Yeah, just write the plus x. Okay, now, so we've gone over this much. Now, when we go across the negative 2x, we took away this 2x squared. We have to write it up there. Minus 2x. Okay? Is that good? I think it's good. Okay. So, we can see it. Now, we've got to count everything that we got over here in this complicated little area here. What we have there is we have negative 2x squared, right? You can see them pretty clearly. So, write that there.
4x. Wait.
Do you see 4x squared?
No, I'm sorry. 2x.
Mm-hmm. Two x what?
Squared.
Yeah. What kind?
Negative.
Yeah.
Right.
Right, you gotta put all the symbols in there.
I forget the symbol.
Right? So we have negative 2x times x. And we got negative 2x squared. Now, what else do we have over there? Underneath, hiding.
Plus 4x.
Mm-hmm. See, and you can even see them, really. Right? You're writing, I'm looking. If you lift up underneath there, there are 2x hiding right there, and 2 more x hiding right there, right? Okay, so that's the 4x that she just wrote. And dude, you gotta try to be a little bit neat for Pete's sakes. Keep them in there.
Plus 4x.
Yeah, keep your rows straight, as they said. You're making me nuts.
Okay.
All right, look. If you're gonna put plus x right there. Okay, then underneath that, there you go. Perfect. I like it. 4x. All right, because negative 2x times negative 2 gives me my plus 4x. Okay, put the line. And now, again, I take this whole quantity and I subtract it. And we're happy because they're the same, so when I subtract, I know it's 0, right? So this is positive. Just put the line. And then put the minus over there. Right? So that means everything underneath there, we're just gonna combine. And this is 0 too. Right?
Right.
Oh wait, were you talking about this?
Yeah.
Okay, that's 0, yes. Okay. Now this over here is what?
Negative 3x.
There you go, look at them. There they are. Negative 3x. So yeah, put negative 3x.
Negative 3x.
There's this guy named Martin. Fletcher. I can't remember his name. Anyway, Martin. He's like, he lives up in the cold area, even colder than where you're going, like Minnesota or something. He'll be enjoying this when he sees it, I'm sure. Okay, so anyway, negative 3x. There you go. Oh, but don't forget what's underneath there. I know you could bring it down too.
Oh, plus 3?
Plus how many?
6.
6. All right, and we don't have I don't have the little pieces because I didn't break them off and put them underneath there, but there would have to be positive 6 underneath there, right? Okay. Using my imagination, there'd be the ones, and if I had my other kit that had all those pieces in it, we could put them underneath there, and it'd be one little thing we could just slide underneath there. But anyway, okay. So minus 3x plus 6. So now we just look over there. What's left? Oh, when I multiply that, I go across how many?
3.
Is it positive or negative 3 that I want?
Negative.
Okay, so put it up there, negative 3.
Negative 3.
So now you have told me what the other side is. And you've also told me what happens as I go down the other side. So when I go down negative 3, I wind up with negative 3 times x gives me negative 3x. Okay, negative 3 times x gives me negative 3x. There, and again, there they are. We're just counting. Just complicated counting. So write down negative 3x.
On the bottom?
Well, yeah, where it goes. And then what? Negative 3 times negative 2. Negative 3 times negative 2.
6.
Yep.
Positive
6. Write the line.
The line.
And then you do it. Put the thing in parentheses. The whole thing. That whole quantity. We subtract it. And we wind up with a positive.
And that's 0.
Right? And that's 0 too. Go ahead and make a mess. I don't care. Alright, so, right? There's nothing there. Done. So now we know there's the answer. Right? X squared minus 2x minus 3. There's the picture of it. There's all the fancy symbols and all the counting that we did. And really, all we're doing, this really brings home the point with this general mathematics when we're doing algebra, is that this just keeps track of the subtraction, right? How many times we count stuff. Okay? Crewton Ramone's House of Math.com for more.